Okay, so the topic is about the properties of determinants. So it is actually section 5.2 of the textbook. So there are three properties of the determinants which we can uh, study today. First property is that if you interchange the row of a matrix, then the determinant of the matrix changes into the sign. So for example, if we have a matrix A with A, B, C, D, and then if we have matrix B with the interchange of rows C, D, A, B, then the determinant of A will be equal to the minus the determinant of B, or determinant of B is equal to the minus the determinant of A. So we can see it easily as well. So for example, this will be AD minus BC, and then this will be BC minus AD. So the sign will change. So with the interchange of the rows, so the determinant will change in the sign. So this is the first property. The second property is that uh, if you multiply any row of the determinant, uh, then the determinant is also multiplied by that number. So for example, if we have determinant A as A, B, C, D, and we have another determinant B in which we have multiplied the first row by a K. So it is AK, BK, then the second row is the same. So the determinant of B will be K times the determinant of A. Okay, it will be K times the determinant. So we can see that determinant of A is AD minus BC. So what is the determinant of B? Determinant of B will be AK times D minus BK times C. So K is common, AD minus BC. So AD minus BC is the determinant of A. So this is the second property of the determinant. And the third property of the determinant is if B is obtained by adding a multiple of one row of A to another, then the determinant of A is equal to the determinant of B, which means that if we, for example, if we add one row to the other or any multiple of that to the determinant, then the determinant, the value of the determinant does not change. So for example, if we have A as A, B, C, D, okay, then if we have B as something like A, B, and then we add, then we multiply A, B by K and then add it to this second row. So that means the second row is C plus AK and D plus BK. So then the value, then the determinant will not change. So we can see it. So we know that the determinant of A is AD minus BC. Determinant of B will be, in this case, A into D plus BK and minus B into C plus AK. So what is this? AD plus ABK, and then minus BC minus ABK. So ABK cancels with ABK. So what we left is AD minus BC. So this, which is the same as the determinant of A. So it means that by the elementary row operations, the determinant does not change. Similarly, another property of the determinant is that determinant of A is equal to the determinant of A transpose. That means if you take the transpose of the matrix, the determinant does not change. So we can see it from here. A is equal to A, B, C, D. Okay. And then A transpose will be, transpose of A will be, what is the transpose of A? A, C, B, D. Interchange of rows and columns. So determinant of A will be AD minus BC, AD minus BC. Determinant of A transpose will be then AD minus BC, AD minus BC. So AD minus BC. So by taking the transpose, the determinant does not change. Okay, so from this property, when we say that from this property, when we say that from this property 3, when we say that by taking the row operations, the determinant does not change. So from here, we can also conclude that if we transform a matrix by taking by the row operations and by the row operations into some echelon form, so then it will be easy to calculate the determinants. Okay. So then it will be easy to calculate the determinants. Similarly, so how? So for example, if we have a 3 by 3 matrix, say for example, or let's take the 2 by 2, okay? I mean, that will be easy to illustrate. A, B, C, D, okay? And then it is transformed into by the row operations. So for example, by the row operations, how we'll transform into the echelon form. So it will be A, B, and then we multiply this by C over minus C over A. So for the first row, we take minus C over A times row 1 plus then row 2, that will be the row 2. Okay. So in this case, what we get is 0 over here, and then this will be B times minus C over A. So it will be minus BC over A. It will be minus BC over A plus DB. Okay. So D minus BC over A. Okay. So now if we see that what is the determinant of this? Okay. The determinant of this is actually simply the multiplication for the elements along the row, because the other one will be 0. So it means that although we have not properly proved it, but we can say that in echelon form, the determinant is the result of product of diagonal elements. Okay, elements. Okay, that means if you multiply the elements on the diagonal, so A will be multiplied by this, so it will be AD minus BC, so which is the same as for this. So in the echelon form, then it becomes easier to find the determinant. Okay. Similarly, the determinant of inverse of a matrix, okay, determinant of inverse of a matrix is equal to 1 over the determinant of A. Okay, 1 over the determinant of A. So determinant of the inverse of the matrix is equal to 1 over the determinant of A. So we can see that from here. If A is A, B, from C, D for 2 by 2 matrix, and we know that its inverse is 1 over AD minus BC into what? D, B, D, B minus C, A. So we know that for 2 by 2 matrix, its inverses can be written like this. So now if we know that the determinant of A is AD minus BC, and then from here, if you want to find the determinant of A inverse, so determinant of A inverse, so what will be that? So this is a scalar 1 over AD minus BC. So what is its determinant? AD and minus BC minus B into minus C. So what is this? This is the this is AD minus BC, okay, and then that is multiplied by, because A and D change this place, and then B and C change the sign. So it will be AD minus BC. So it will be minus BC. So AD minus BC, that will be 1. Determinant of A inverse. So yeah, we know that determinant of A inverse is equal to 1 over the determinant of A. Yes, so it will be, if the determinant of A is this, so determinant of A inverse will be 1 over AD minus BC, right? So 1 over determinant of A inverse should be 1 over AD minus. So that means this value should be 1. But is it? Apparently I am making some mistake somewhere. 1 over AD minus BC, and this will be A from our previous rule, which I know that A and D interchange the places. So D comes here and A comes here, and B and C change the sign. So minus B and minus C, which is correct. And yeah, so A1 over AD minus BC is here, and then it's AD minus minus BC. So that is AD minus, should be AD minus BC. So AD minus BC cancels with AD. So that means the determinant of A inverse is 1. There is something.
Sorry, isn't just A inverse 1, not the determinant of A inverse? Like by the formula 1 over AD minus BC and the matrix that you wrote, it is A inverse.
Yes, A inverse is, so if A is this, so then A inverse is given by this formula, right?
Yes.
A is inverse, A inverse is given by this formula. And then that means A1 over AD minus BC is on the outside, and then D minus B minus C over A. So it's the determinant, which should be D times A minus plus B. So something is wrong. Something is not correct. The determinant of A inverse should be actually this, according to this formula, 1 over AD minus BC. So this means that means this value should be 1. Okay. I don't know what's happening over here. Anyway, I will not try to prove it anyway. This formula is okay. And then if I find the answer later on, then I will explain it in some separate video. So one more property for the determinant is that the determinant of a to the power m, where m is an integer, is equal to the determinant of a whole power m. Okay, so this is also the one of the property. So this can be used. Okay, let's see some examples.
Sorry, here when you say that in echelon form, determinant is the result of product of diagonal elements, does it apply to any other, for example, 3 by 3 matrix?
Yes, for any order of the matrix.
Okay, thank you.
Okay, so let's find the determinant. So let's see some of the examples. Okay. So for example, if we have a determinant of A as a matrix A, 2, 4, 1, minus 4. So easily we can find its determinant like 2 into minus 4 minus 4 into 1. So it is minus 8 minus 4 is minus 12. However, if we transform this matrix into the echelon form, so what we can do is 2, 4, and then 1, it will we will apply the row operation minus 1 by 2, row 1 plus R2, that will be R2. So it will be 0, and then it will be minus 2, minus 4 plus minus 4 minus 2, that will be minus 6. And then if now it is in the echelon form, its determinant is equal to 2 times minus 6, the multiplication of the elements on the diagonal. So it is minus 12, which is the same. Okay. However, actually for 2 by 2 matrix, it is simple, but for this rule can be very useful for 3 by 3 matrices. So for example, in this case, 3 by 3 or even 4 by 4 or higher order matrices for hand calculation. So 0, 1, minus 2, and 1, 3, 4, and 0, 2, 2. Okay, 0, 1, minus 2, 1, 3, 4, 0, 2, 2. Okay, so this is the 3 by 3 matrix. So suppose we want to find the determinant of this matrix. Actually, by this column expansion, it is also easy to find. So for example, because in this column, 2 of the elements are 0. So if we expand it by this column, so for example, if we take like for 3 by 3 matrix, like what we have is the signs will change. So for example, this is the second row, first element, so the sign will be a minus. So minus 1, because it will be minus 1 power I plus j. So I is here 2 and j is 1. So it is minus 1 power 3 is minus 1, and times 1. And then its minor matrices 1, minus 2, and 2, 2. So its determinant can be now easily found 2 and then plus 4. So it will be minus 6. Okay. So the determinant is minus 6. However, if we apply the row operation, so we can alternatively also find its determinant, which will be the same answer. So for the row operations, what we have to do is it will be easier if we interchange these two rows. Okay, so to make it into the echelon form. So what we will do is 1, 3, 4, 0, 1, minus 2, and then 0, 2, 2. So what row operation we have performed is row 1 has been interchanged with row 2. Okay, but for the interchange of the row, we know that the sign of the determinant will change. So from plus to minus, or from minus to plus. So in order to make it into the echelon form, so this first column, these elements are 0 and 0 over here. In the second column, we have to make this element as 0. So we will apply a row operation like what will be the row operation? Minus 2 times row 2 plus row 3 is equal to row 3. So it will be 1, 3, 4, and now 0, 1, minus 2. And you can see that from here. So 2 minus 2 is 0. And then we are going to multiply by minus 2. It should be plus 4 plus 2 is 6. So now you can see that this matrix is in the echelon form. So its determinant will be then 1 into 1 into 6, and then we have to put a minus sign over here because we interchange the row one time. So it will be minus 6, which is the same answer as before. Okay, clear? Okay, so one more example for finding the determinant. In this time, a 4 by 4 matrix. So it is 1, 1, 2, 1, 2, 2, 1, minus 2. Okay, 0, 1, 1, 2, and then minus 3, 3, 2, 0. So if this is the matrix 4 by 4 matrix, and we want to determine its determinant. So if we, for example, if we apply this cofactor, this method over here by deleting and then the corresponding rows and columns, and then applying the minor matrix method, that will be very long. So the simple way will be perform the row operations to make it into the echelon form. So what row operation we will apply? So we want to make this 2 as 0 and then minus 3 as 0. So it will be 1, 1, 2, 1, and then 2 minus 2 will be 0, 2 minus 2 will be 0, 1 minus 4 will be minus 3, okay, and then minus 2 will be minus 2 will be minus 4, okay, and now you will have 0, 1, 1, 2, and then from here, so the first row operation is minus 2 row 1 plus row 2, that is the new row 2, and the second row operation will be 3 row 1 plus row 4, that is the new row 4. So this row will be minus 3 plus 3, that is 0, 3 plus 3, that is 6, and then 2 plus 6, that will be 8, and 0 plus 3, that will be 3. Okay, 0, 6, 8, 3, that will be the fourth row. Okay. So now we can see that this second row has an element which is a diagonal element as 0. So this will be not very useful for us for finding the determinant. So therefore, what we can do is we can interchange the second and the third row. So 1, 1, 2, 1. So it will be 0, 1, 1, 2, and then it will be 0, 0, minus 3, minus 4, and 0, 6, 8, 3. So what row operation we have done over here is we have interchanged the rows 2 and row 3. Okay, so in this case, the later on the determinant will change by one sign. So now for making it into the echelon form, what we can do is 1, 1, 2, 1, and then 0, 1, 1, 2. So this is already 0. So 0, 0, minus 3, minus 4. And we can make this as 6 as 0. So 0, 0. So because we need to multiply this second row by minus 6. So it will be 8 minus 6. That will be 2. And then this will be minus 12. Okay, minus 12 plus 3 is minus 9. Minus 9. So the row operation over here is minus 6 row 2 plus row 4. That is the new row 4. Okay. So for the next row operation, so we can write like 1, 1, 2, 1, 0, 1, 1, 2, and then 0, 0, minus 3, minus 4, 0, 0, minus 3, minus 4. And now for this one, we need to make this 2 as 0. Okay, so making 2 as 0, so this should be a minus 2 over here. So for so this means that for this minus 3, so we need to multiply by we need to divide by 3. So 3 cancels with 3, then 2. So it will be means we need to multiply by 2 by 3. So that will make it minus 2. So 2 minus 2, that is 0. So 0, 0, and then 0 over here. And then this is minus 4. So minus 4 multiplied by 2 by 3. So it is minus 8 by 3. So it is minus 8 by 3. Minus 8 by 3 plus 9, minus 9. Okay, so minus 9. So it will be minus 35 by 3. It will be minus 35 by 3. So it will be 0, 0, minus 35 by 3. So this is the final row echelon matrix. So this row operation was 2/3 of row 3 plus row 4. That is the new row 4. So now this is the row echelon form. So for example, 1, 0, 1, 0, 0, and then this is the pivot row, and then 0, 0, 0, and then this is the pivot row. So what will be the determinant in this case? The determinant in this case will be 1 times 1 times minus 3 and times minus 35 by 3. And then minus sign over here, because for one time we have interchanged the rows. So therefore, what we get is, what is the final answer we got?
Minus 35.
Yeah, minus 35. Minus 35. Okay, so so this is this type of method when reducing into the row echelon form gives you some relatively simple and less time consuming solution for when the matrices are 3 by 4 or much bigger. Okay, so that is the thing. Okay, next.
So this, sorry, this can be applied to only to square matrices, yes?
Yeah, determinants are always for square matrices. So determinants are not defined for rectangular matrices.
Okay, thank you.
Okay, so yes, just a short example. So suppose if we have A is equal to 1 minus 3, 2 minus 5. And if we apply a row operation R1 interchange with R2, so then what happens? So if we apply this row operation R1 to the R2, so this matrix will be wait a minute. So if we apply this row operation when R1 is interchanged with R2, so what we will get is 2 minus 5, 1 minus 3. So what is the determinant of this A? That will be 1 into minus 5 minus 3 into 2. So it is minus 5 plus 6, so it is 1. And then here, what will be the determinant? Suppose this is B, so determinant of B will be 2 into minus 3, and then minus 5 into 1. So it is minus 6 plus 5, so it is minus 1. So this, which means that by interchanging the rows, the determinant changes sign. Okay, so I think we have already done this. I don't need to repeat this type of example. Okay, so now let's find the determinant as some added example for this 1, 1, 1, 1, 1, a 5 by 5 matrix. So it is 1, 2, 2, 2, 2. So it is 1, 2, then 3, 3, 3, and then 1, 2, 3, 4, 4. And then it is 1, 2, 3, 4, and then 7. So what will be its determinant? So this is actually a specially crafted matrix. And then the final answer will be much simplified. So if you will apply the row operations, so what you will do is 1, 1, 1, 1, 1, and then row minus row 1. Okay, so the row operation will be minus row 1 plus row 2, that is the row 2. So you will get 1, 0, 1, 1, 1, 1. Okay. And then another row operation minus row 1 plus row 3, that is row 3. So you will get 1, 0, 0, 2, 2, 2. Okay. And sorry, not 0, 0, 0, 1, 2, 2, 2. Yeah, 0, 1, 2, 2. So, 0, 1, 2, 2, 2. You will get 0, 1, 2, 2. And for this minus row 1 plus R4, that is the new R4. Similarly, minus row 1 plus row 5, you will get R5. Anyway, these are the simple operations. It's very easy to understand. So you will get 0, 1, 2, 3, 3, and then you will get 0, 1, 2, 3, 6. Okay, so now I need to make these three values as 0, so it should be 1, 1, 1, 1, 1, and then 0, 1, 1, 1, 1, and then it will be 0, 1. So it should be now 0, 0. Okay, 0, 0. Now 1, 1, 1, and then it will be 0, 0, 1, 2, 2, and then you will get 0, 0, 1, 2, 5. So it means that you can see that this value 7 has changed to 6 to change to 5. And next row operation will give this matrix 1, 1, 1, 1, 1. That will be 0, 1, 1, 1, 1. That will be 0, 0, 1, 1, 1. And then that will be 0, 0, 0, 1, 1. And the last one will be 0, 0, 0, 1, 4. And then lastly, you will get this matrix. So 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, and then 0, 0, 0, 1, 1, and then the last row will be 0, 0, 0, 1, and then 4. So this will be a 5 by 5 matrix. Actually, these will be the diagonal members 0, 1, 1, 1, and then 4. The last one will be actually not 4. 4 minus 1 is 3. So it should be 3. The last one will be 3. So what will be the determinant then? So the determinant will be then how many times 1? 1 times 1 times 1 times 1 times 3. So that is the 3. So in this case, the determinant is simply the 3. Okay, is it clear?
Yes.
Okay, next, one more example. So if determinant of A is, if determinant of A is 3 and determinant of B is minus 2. So suppose if we have two matrices, determinant of A is 3, determinant of B is minus 2, then what will be the determinant of AB? Okay, so from the properties of the determinant, we know that determinant of AB is equal to determinant of A times the determinant of B. So we know that the determinant of A is 3, determinant of B is minus 2, so the determinant of AB will be minus 6. So this will be the answer. And how about determinant of B inverse A? How about the determinant of B inverse A? So this we can find by, for example, first we take B inverse, the determinant of B inverse times the determinant of A. And we know that the determinant of B inverse, although we I made some mistake to prove it, but we know that the determinant of B inverse was determinant of 1 over the determinant of B into, then this is the determinant of A. So what is the determinant of B is minus 2. Determinant of BA is 3, so it is minus 3 by 2. So this is the, and if in this case, what is the determinant of, say, determinant of B cube, A, B minus cube. So determinant of B cube means the matrix B is multiplied with B like this. So B multiplied by B, and then that is multiplied by B. So that is B cube in the matrix form. It is the matrix product 3 times. So in this case, we know that it is the determinant of B cube times the determinant of A times the determinant of B minus 3. Okay, for this, we know that determinant of B cube is determinant of B and then whole cube, okay, and then the determinant of A, and similarly the determinant of B minus 3, that will be the determinant of B whole minus cube. So determinant of B cube and determinant of B minus cube, that is both like 1, because we know that x cube into x minus 3 is just similar like in the algebra. We have x power 3 minus 3, x power 0, that is equal to 1. So therefore determinant of B cube into determinant of B minus cube, and then that will be equal to 1. So what we left is determinant of A, which is equal to 3. So this is the answer. The fourth one is what is the determinant of AB transpose, AB transpose times determinant of A inverse, this one. So we take AB and then take its transpose and then multiply it by A inverse. So first we take the product, separate the product. So determinant of AB transpose okay, and then this will be the determinant of A inverse. So now we know that determinant of AB transpose means, we know that AB transpose is equal to B transpose into A transpose. Okay, so this we can write down like this: determinant of B transpose into A transpose. And then determinant of A inverse means that determinant of A. And from here we can find that it is determinant of B transpose into determinant of A transpose, okay, divided by determinant of A. Okay, so now, but we know that the determinant of the transpose is the same as for the original. So it means that determinant of B transpose is basically determinant of B, and determinant of A transpose is determinant of A, and then divided by determinant of A. So determinant of A cancels this determinant of A. So what we left is determinant of B, and the determinant of B is minus 2. So the final answer is minus 2. Okay. So in this case, we have done some examples of the determinants. Our next topic will be the application of. It will be the next topic will be the next class. Application of determinants. So the application of the determinant is mainly to find the solution of the system of linear equations by the Cramer's rule. And also the second application is the to find the determinant, to find the inverse of a matrix using the determinant. So these two applications we will discuss in the next class, and then we will move to the topics of the eigenvalues. And also in parallel, I am also uploading some other videos related with the matrices and the basis, etc. So yeah, so I think we are quite much on the schedule. So hopefully we will be completing everything in the after the next 2 weeks. So maybe the last week or even 1 or 2 lecture before, we can have some time for the revision as well. So by the end of this week, you will be also given one more assignment for Mathematica. That will be the last assignment for you before your final exam. So do you have any questions?
No.
No.
Okay. No questions. Okay. Then that's good. So let me stop the